Batteries are very limited today. Their ability to store a lot of power is not dramatically better than 50 years ago. And yet for new energy systems where you're collecting from the sun or wind, which are intermittent, we're going to need batteries that are 100 times better to really solve this problem. But it'll have to be big, 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 and cheap, cheap, cheap.
Principles of the liquid metal battery are the same principles of any battery. You've got two electrodes separated by an electrolyte, and that's how we generate electricity. And what makes the liquid metal battery different is that every component is the liquid. So you have a high density liquid metal that lies on the bottom of the cell, and it's covered by the molten salt electrolyte. And on top of the molten salt electrolyte is a low density liquid metal. And that difference in composition between the two liquid metals gives rise to a voltage.
And the beauty of it being all liquid is that instead of building a large capacity installation by taking thousands and thousands of individual cells, each of them say the size of a soda can, and then stringing them all together with the attendant cost and complexity, we can build a giant battery of comparable capacity with far fewer cells. We figure 50 to 100 times fewer. And that's going to reduce the cost.
New approaches, like the liquid metal approach, may be the answer. If we can find the right compounds, then we can break out of today's battery design. And Professor Sadoway's work really makes him uniquely qualified because it's these properties of different alloys that will let us make a magic battery.